Some visitors carry the memory of worlds that no longer exist. When 3I Atlas emerged from the depths of interstellar space, it arrived not as a conqueror or explorer, but as something far more haunting, a wanderer bearing the chemical signature of destruction, the luminous ghost of a planet that once was. In its strange glow and impossible trajectory, astronomers would discover echoes of the greatest mystery in our solar system, the missing world that should orbit between Mars and Jupiter, but instead exists only as scattered fragments and ancient myths. Picture the moment of its first detection. Automated telescopes capturing light that had travelled unimaginable distances, carrying within its photons the story of catastrophe written in starfire and shadow. Unlike the familiar visitors we've learned to expect, comets trailing their predictable tails of ice and dust, asteroids tumbling dark and cold through the void, this newcomer blazed with its own inexplicable radiance, as if lit from within by memories of a sun that no longer shines on the world it once knew. The Discovery teams knew immediately they were observing something unprecedented. Where Oumuamua had been dark and enigmatic, where Borisov had behaved like any ordinary comet from the outer reaches of another star system, 3I Atlas announced itself with a luminosity that defied every model of how interstellar objects should appear. It glowed with the steady, mournful fire of something that had lost its home among the stars and now wandered the cosmic dark, carrying its own light because it had nowhere else to belong. But it was the trajectory analysis that first hinted at mysteries deeper than simple interstellar origin. When orbital mechanics specialists traced the visitor's path backward through space and time, following the gravitational mathematics that govern all celestial motion, they discovered something that made them pause and recalculate their equations. The trajectory didn't trace back to the expected depths of interstellar space, didn't follow the smooth hyperbolic curve of an object arriving from another star system. Instead, the path curved back toward a region of space that astronomers knew all too well, the asteroid belt, that scattered graveyard of rock and metal that orbits between Mars and Jupiter. But this wasn't the trajectory of debris casually ejected from the belt's chaotic dynamics. This was something else entirely, a path that suggested the visitor had been flung from that region with tremendous force, sent careening into the outer darkness by some catastrophic event that had occurred long before human eyes ever turned toward the stars. The implications were staggering. If 3I Atlas had indeed originated from our own solar system, if it had been cast into interstellar exile by some ancient violence, then its return represented something unprecedented in astronomical observation. A piece of our cosmic neighbourhood coming home after eons of wandering in the void between stars. Do you think some objects in space might be refugees from disasters so old that we've forgotten they ever happened? Share your thoughts as we explore this possibility that challenges everything we thought we knew about our celestial family. The spectral analysis deepened the mystery. When astronomers broke down the visitor's light into its component wavelengths, they discovered a chemical signature that seemed oddly familiar, yet impossibly out of place. The elements detected in its luminous glow matched isotope ratios found in certain meteorites that had puzzled researchers for decades. Fragments that didn't fit the standard models of solar system formation, specimens that seemed to carry the chemical fingerprints of processes that shouldn't exist in our cosmic neighbourhood. These anomalous meteorites had always been curiosities, outliers in the grand catalogue of space debris that rains down on Earth. Their exotic metal compositions, their unusual crystalline structures, their isotope ratios that spoke of formation under conditions unlike anything in our current solar system. All had been dismissed as interesting but ultimately minor mysteries, perhaps the products of rare stellar events or unusual nebular chemistry. But 3I Atlas blazed with the same impossible signature, carried the same chemical echoes of processes that defied explanation. It was as if the visitor served as a Rosetta Stone for these puzzling fragments, a luminous key that might unlock secrets about their true origin and significance. The size estimates made the mystery even more profound. Unlike typical interstellar visitors, which tend to be modest chunks of ice and rock barely large enough to survive their journey between stars, 3I Atlas appeared to be massive, a substantial body that had somehow maintained its structural integrity through whatever cataclysmic event had sent it into exile, then survived the brutal environment of interstellar space for what must have been millions or tens of millions of years. Such endurance suggested composition beyond ordinary rock and ice. The visitor seemed to be made of sterner stuff, materials forged under conditions of extreme pressure and temperature, substances that could maintain their coherence across cosmic time and distance. It was a survivor in the truest sense, a refugee from some ancient disaster that had somehow preserved not just its physical structure, but it to generate its own mysterious luminosity. As the nights passed and observations continued, a haunting picture began to emerge. 3I Atlas moved through our solar system, not with the confident trajectory of a tourist from another star, but with something that felt almost like recognition. Its path carried it past familiar landmarks, the orbit of Jupiter, the scattered debris of the asteroid belt, the gravitational architecture that had shaped our cosmic neighborhood for billions of years. There was something almost mournful about its journey, a quality that observers struggled to articulate but couldn't ignore. It traveled like something returning to a place that had once been home, now changed beyond recognition. The steady glow that had first captured astronomical attention seemed less like a beacon of exploration and more like a memorial flame, burning in tribute to something lost beyond recovery. The visitor's luminosity remained constant as it passed through regions of space where its ancient siblings still orbited, the asteroids and minor planets that populated the belt between Mars and Jupiter. These fragments, scattered across millions of cubic kilometers of space, represented the largest collection of primitive solar system materials available for study. Yet none of them shared the visitor's mysterious glow. None carried the same spectral signature that spoke of exotic processes and impossible chemistry. 3I Atlas stood apart even from its potential siblings, unique in its ability to generate light, distinct in its chemical composition, separate in its long exile and dramatic return. It was the prodigal child of the solar system, the lost fragment that had somehow found its way back to the scene of whatever ancient catastrophe had shaped its destiny. But what kind of event could have created such a visitor? What force could have been powerful enough to fling a substantial body completely out of the solar system, sending it on a journey that lasted millions of years before gravity and chance brought it back to the neighborhood of its birth? And what did its return mean for our understanding of the violent processes that had shaped our cosmic home? The answers lay hidden in one of astronomy's most enduring mysteries, the riddle of the missing planet, the world that mathematical models insisted should exist, but observation had never found. For centuries, astronomers had puzzled over the gap in the solar system's architecture, the empty space where planetary formation models predicted a substantial world should have taken shape. Could 3I Atlas carry within its luminous heart the story of that lost planet? Could its exotic chemistry and impossible glow be the last surviving testimony to a world that had been destroyed so completely that only scattered fragments and wandering exiles remained to mark its passing? As our cosmic visitor continued its patient journey through the realm of its shattered siblings, astronomers began to wonder if they were witnessing not just the return of an interstellar wanderer, but the homecoming of a world's last surviving child, carrying in its heart the memory of a catastrophe so ancient that only the stars remember when the missing planet died, long before telescopes revealed the true architecture of our solar system, long before we understood the gravitational ballet that keeps worlds in their ordained places. Human minds sensed that something was missing from the celestial order. The gap was mathematical before it was observational, a wound in the harmony of planetary motion that demanded explanation, even when the tools to find that explanation didn't yet exist. The story begins with Johann Bode, an 18th century German astronomer whose fascination with celestial mechanics led him to discover a remarkable pattern hidden in the orbital distances of the known planets. What became known as Bode's law revealed that planetary orbits followed a mathematical progression so precise it seemed to encode some fundamental principle of cosmic architecture. Each world orbited at a distance that could be predicted by a simple formula, a celestial music written in the language of mathematics and gravitational harmony. But the pattern contained a troubling gap. Between Mars and Jupiter, where Bode's law predicted a planet should orbit at a distance of 2.8 astronomical units from the Sun, there was only empty space. The mathematical harmony demanded a world at that location, yet none could be found. It was as if a note had been struck from the cosmic symphony, leaving a silence that resonated through all subsequent observations. When astronomers finally discovered Ceres in 1801, orbiting precisely where Bode's law had predicted a planet should exist, there was initial celebration. The missing world had been found at last, the gap in the celestial architecture filled. But as more objects were discovered in the same region, Pallas, Juno, Vesta, it became clear that instead of one substantial world, this orbital zone contained a multitude of fragments, a scattered debris field that would eventually be recognized as the asteroid belt. The implications were profound and troubling. Rather than finding the predicted planet, astronomers had discovered what appeared to be its remains. The mathematical harmony of planetary motion had been preserved, but only in the form of countless fragments orbiting where a single world should have been. It was as if they had found the scene of some ancient catastrophe, a cosmic crime scene where the evidence of violence was written across millions of kilometers of space. Heinrich Olbers, the German astronomer who discovered both Pallas and Vesta, was among the first to articulate the revolutionary hypothesis that would haunt astronomy for centuries to come. In his careful analysis of these new worlds and their peculiar orbital characteristics, Olbers proposed that they were not separate objects that had formed independently, but fragments of a single larger body that had been destroyed by some catastrophic event. The destroyed planet hypothesis, as it came to be known, suggested that our solar system had once contained an additional world orbiting between Mars and Jupiter. This hypothetical planet, sometimes called Phaeton after the Greek myth of the charioteer who drove too close to the sun, had somehow been shattered so completely that only scattered debris remained to mark its former presence. Olbers's contemporaries greeted this proposal with skepticism. The idea that an entire planet could be destroyed seemed to violate the fundamental stability that characterized planetary motion. Worlds were permanent fixtures of the cosmic order, ancient and enduring beyond human comprehension. The notion that one could be obliterated challenged basic assumptions about the nature of celestial mechanics and the forces that governed the solar system. But as the 19th century progressed and more asteroids were discovered in the predicted orbital zone, the evidence for some form of catastrophic origin became increasingly difficult to ignore. The fragments didn't behave like objects that had formed in place through normal accretion processes. Their orbits were too scattered, their compositions too varied, their size distribution too chaotic to represent the natural products of planetary formation. Immanuel Kant, the great philosopher who had also contributed groundbreaking insights into astronomy and cosmology, found himself drawn to contemplate the implications of a destroyed world. In his reflections on the nature of cosmic violence and the forces that shaped celestial architecture, Kant suggested that the destruction of planets might be a natural, if rare, consequence of the same gravitational forces that created them. What could build worlds could also tear them apart under the right circumstances. The mathematical analysis of asteroid orbits revealed additional clues that supported the catastrophic hypothesis. Many of these fragments followed elliptical paths that intersected at common points, as if they had been flung outward from a central location by some explosive force. The velocity distribution suggested that whatever had destroyed the original body had done so with tremendous energy, imparting enough momentum to some fragments to send them careening toward the inner or outer solar system. Modern computational techniques have allowed astronomers to trace these orbital relationships backward through time, mapping the gravitational evolution of the asteroid belt across millions of years. The results consistently point toward a period of intense disruption, approximately 4 billion years ago, during the solar system's early history, when planetary formation was still ongoing and gravitational interactions were more chaotic and violent than they are today. The timing coincides with what scientists now call the Late Heavy Bombardment, a period when the inner planets were subjected to intense meteor impacts that scarred their surfaces and delivered vast quantities of water and organic compounds to worlds like Earth. If the missing planet was indeed destroyed during this epoch, its fragments would have contributed significantly to this cosmic cataclysm, raining debris throughout the solar system and fundamentally altering the development of the surviving worlds. The chemical composition of asteroids provides perhaps the most compelling evidence for the destroyed planet hypothesis. Rather than showing the uniform characteristics that would be expected if they had formed independently in the same orbital zone, asteroid compositions vary dramatically from fragment to fragment. Some are rich in metals, suggesting they formed in the core of a differentiated planet. Others show the rocky characteristics of a world's mantle or the icy signatures of surface materials. This chemical diversity implies that the asteroids represent cross-sections through what was once a complete planetary body, fragments that sample every layer from the metallic core to the icy surface, now scattered across millions of cubic kilometers and providing a unique opportunity to study the internal structure of a world that no longer exists as a coherent entity. The isotope ratios found in certain meteorites that have fallen to Earth further support this interpretation. These space rocks carry chemical signatures that don't match the expected composition of objects formed in the asteroid belt's current environment. Instead, they suggest formation under conditions of higher temperature and pressure, consistent with origins in the interior of a substantial planetary body that was later disrupted. Some of the most exotic meteorites in our collections, those with unusual metal alloys, rare crystalline structures, and isotope compositions that puzzle geochemists, may be samples from the missing planet's core, fragments of a world's heart that have survived the destruction of everything around them. Each of these specimens represents a piece of direct evidence for the catastrophic hypothesis, a tangible remnant of a world that existed long before human civilization arose on Earth. The gravitational modelling of how such a destruction might have occurred has evolved significantly with advances in computational astronomy. Current simulations suggest that the missing planet could have been shattered by a collision with another substantial body during the solar system's chaotic early period, or by gravitational disruption caused by the migration of the giant planets through different orbital configurations than they occupy today. The precision required for complete planetary destruction is staggering. The impacting body would need to be roughly 1/10 the mass of the target planet, arriving at a specific angle and velocity to maximize the disruption, while minimizing the formation of large surviving fragments. The mathematical elegance of such destruction mirrors the mathematical harmony that Bode had discovered in planetary orbits, suggesting that creation and destruction in the cosmos follow equally precise and beautiful laws. But perhaps the most haunting aspect of the destroyed planet hypothesis is its implication for the nature of cosmic permanence. If worlds can be unmade as easily as they are made, if entire planets can be reduced to scattered debris by the same gravitational forces that brought them into existence, then the stability we observe in our solar system represents not an eternal state, but a temporary equilibrium that could be disrupted under the right circumstances. The missing planet's destruction would have been visible from Earth as a brilliant light in the sky, perhaps outshining even Venus for months or years, as the shattered debris heated and glowed from the energy of the collision. Ancient observers might have witnessed this cosmic catastrophe as a new star that appeared suddenly in the constellation where the asteroid belt now resides, blazing with the funeral pyre of an entire world before gradually fading as the debris cooled and dispersed. Could 3I Atlas represent something even more profound than a fragment of the destroyed world? Could it be a piece that was flung so far from the scene of destruction that it escaped into interstellar space, only now returning after eons of exile to rejoin its scattered siblings in their eternal orbit around the scene of their birth? In the hushed halls of meteorite laboratories around the world, scientists encounter specimens that challenge everything we thought we knew about the formation of our solar system. These are not ordinary space rocks, not the familiar iron-nickel fragments or stony chondrites that make up the bulk of cosmic debris falling to Earth. These are anomalies, fragments so exotic in their composition, so impossible in their structure, that they seem to carry the chemical fingerprints of processes that shouldn't exist in our cosmic neighborhood. The most famous of these enigmatic visitors is the Allende meteorite, a specimen that fell to Earth in Mexico in 1969, scattering its mysterious fragments across the Chihuahuan desert like breadcrumbs from some cosmic bakery that operates by unknown recipes. When geochemists began their analysis of this 4.5 billion-year-old time capsule, they discovered isotope ratios that defied explanation, crystalline structures that shouldn't be stable under normal conditions, and mineral compositions that suggested formation under pressures and temperatures far exceeding anything found in typical asteroids. The calcium-aluminum inclusions within Allende, microscopic white specks that astronomers believe represent the oldest solid materials in our solar system, contain isotopic signatures that speak of stellar processes occurring under conditions unlike anything in our current cosmic environment. These inclusions appear to have been forged in the heart of dying stars, then somehow incorporated into planetary materials through mechanisms that current models struggle to explain. But Alendi is just one member of a growing catalogue of impossible specimens. The Murchison meteorite, which fell in Australia in 1969, carries within its carbon-rich matrix organic compounds so complex and varied that they seem to represent an entire library of prebiotic chemistry. Molecular recipes that could have served as the building blocks for life itself, yet formed under conditions that remain mysterious to contemporary science. The Nakla meteorite, ejected from Mars by some ancient impact and eventually captured by Earth's gravity after millions of years wandering through space, contains mineral structures that suggest the presence of liquid water on the red planet's surface, long after geological models predicted it should have frozen solid. Each specimen tells a story that doesn't quite fit the narrative we've constructed about planetary formation and evolution. These anomalous meteorites share certain characteristics that set them apart from their more mundane cousins. They contain exotic metal alloys, combinations of elements that shouldn't be stable under the conditions present in typical asteroid environments. Their crystalline structures show evidence of formation under extreme pressures, suggesting origins deep within substantial planetary bodies, rather than in the low-gravity environment of small asteroids. Most intriguingly, many display isotopic signatures that don't match the expected composition of materials formed in our solar system's current configuration. The isotope ratios are particularly puzzling. Different elements exist in multiple forms, isotopes with varying numbers of neutrons in their atomic nuclei. The relative abundance of these isotopes serves as a kind of chemical fingerprint, revealing the conditions under which materials formed and the stellar processes that created them. In our solar system, these ratios follow predictable patterns based on the composition of the original nebular cloud that condensed to form the Sun and planets. But the anomalous meteorites show isotope signatures that suggest formation in environments with different stellar chemistry, under different pressure and temperature regimes, or through nucleosynthetic processes that don't match our current models of solar system formation. It's as if they carry chemical memories of a different cosmic neighbourhood, or of conditions that existed in our region of space at times when the local environment was dramatically different from what we observe today. When 3I Atlas blazed across our telescopes with its impossible luminosity, spectroscopic analysis revealed something that made meteorite specialists around the world pause and reconsider their carefully catalogued collections. The visitor's chemical signature matched with uncanny precision the exotic isotope ratios found in the most anomalous meteorites in our laboratories. Elements that shouldn't exist in those proportions, crystalline structures that suggested formation under impossible conditions, metal alloys that seemed to encode the memory of stellar processes unlike anything in our current cosmic environment. The connection was more than just coincidental similarity. It was as if 3I Atlas served as a Rosetta Stone for the anomalous meteorites, providing the missing context that could finally explain their origins. If the visitor had indeed originated from the destroyed planet between Mars and Jupiter, if it represented a substantial fragment that had been ejected from our solar system during that ancient catastrophe, then its chemical composition might preserve a record of conditions that existed when planetary formation was still ongoing. The destroyed world, if it had existed, would have formed during the solar system's earliest epoch, when the nebular environment was still rich in exotic materials and stellar debris from previous generations of stars. The chemical signatures now found in anomalous meteorites might represent samples from this primordial planetary body, fragments that preserve the memory of formation conditions that no longer exist in our cosmic neighbourhood. 3I Atlas, in this interpretation, becomes something far more significant than just another interstellar visitor. It represents a time capsule from our solar system's violent youth, a messenger carrying information about the chemical and physical processes that shaped planetary formation during an epoch when conditions were dramatically different from what we observe today. Its exotic glow might result from radioactive decay of elements that were incorporated into the original planet during its formation. Isotopes with half-lives so long that they're still producing energy billions of years after the world that contained them was shattered. The mathematical modelling of how such exotic materials could survive intact through the trauma of planetary destruction and subsequent interstellar exile reveals the incredible resilience of certain crystalline structures under extreme conditions. Some mineral formations, once established under high pressure and temperature, maintain their integrity even when the world that created them is blown apart. These materials become cosmic archives, preserving detailed records of the conditions under which they formed long after those conditions have ceased to exist. The size distribution of anomalous meteorites provides additional clues about their possible connection to 3I Atlas and the destroyed planet hypothesis. While ordinary meteorites show the random size distribution expected from fragmentation of typical asteroids, the exotic specimens tend to be either very small, microscopic grains and tiny fragments, or occasionally quite large, as if the destruction process that created them was particularly efficient at either pulverizing material completely or preserving substantial chunks intact. 3I Atlas, with its impressive dimensions and obvious structural coherence after millions of years in interstellar space, represents the extreme end of this preservation spectrum. If it is indeed a fragment of the destroyed world, it would be one of the largest pieces to survive the catastrophic disruption, possibly a chunk of the original planet's core or mantle that was massive enough to maintain its integrity through both the destruction event and the subsequent journey through the cosmic void. The visitor's luminosity takes on new significance when viewed as a consequence of exotic radioactive decay occurring within materials formed under the extreme conditions present during the early solar system's formation. Elements created during the destruction event itself, through nuclear processes triggered by the catastrophic collision, might still be producing energy at detectable levels, creating the steady glow that first captured our attention and defied conventional explanations. Laboratory analysis of the most exotic meteorites has revealed trace amounts of elements that shouldn't exist in nature, isotopes with such short half-lives that their presence in 4-billion-year-old specimens suggests they were created through recent nuclear processes rather than primordial formation. If 3I Atlas contains similar materials, its glow might represent ongoing nuclear decay of elements created during the moment of planetary destruction, a cosmic funeral pyre that has burned for millions of years as the fragment wandered through interstellar space. The crystalline structures found in anomalous meteorites also provide clues about the extreme conditions that existed during the destroyed planet's final moments. Some minerals show evidence of formation under shock pressures exceeding those found anywhere else in the solar system, suggesting that the destruction event generated forces capable of creating entirely new forms of matter. These shock metamorphosed materials carry within their atomic structure a permanent record of the violence that ended their parent world's existence. 3I Atlas, if it represents a substantial fragment of this destroyed world, might contain vast quantities of such shock metamorphosed materials, exotic crystalline forms that exist nowhere else in the solar system, and that preserve detailed information about the physics of planetary destruction. Each mineral grain would serve as a microscopic witness to the catastrophic collision that shattered an entire world, encoding in its atomic structure the pressures, temperatures, and chemical conditions that existed during those final violent moments. The magnetic properties of anomalous meteorites reveal another layer of mystery. Many contain mineral structures that preserve the magnetic field orientation present at the time of their formation, creating a kind of fossilized compass that points toward magnetic north as it existed billions of years ago. But some specimens show magnetic orientations that don't match the expected field geometry for objects formed in our solar system's current configuration, suggesting origins in environments where different magnetic field structures existed. If 3I Atlas originated from the destroyed planet, its internal magnetic structure might preserve a record of that world's magnetic field, information that could reveal details about the planet's core composition, rotation rate, and internal structure that would otherwise be impossible to obtain. The visitor becomes not just a fragment of a destroyed world, but a cosmic hard drive containing archived information about planetary processes that occurred billions of years ago. As 3I Atlas continues its patient journey through the realm of its scattered siblings, carrying within its luminous heart the chemical memory of impossible processes and extinct conditions, we begin to realize that some cosmic visitors are more than mere debris. They are libraries written in stone and metal, preserving the stories of worlds that died before Earth learned to dream. Deep within humanity's oldest stories, buried beneath layers of metaphor and symbolism, there may lie memories of cosmic events so traumatic that they burn themselves into our collective unconscious, and have echoed through every retelling across millennia. What if the mythologies that speak of shattered worlds, of primordial catastrophes that reshaped the heavens, preserve not just the poetry of human imagination, but actual witness accounts of planetary destruction transmitted across countless generations of storytellers? In the ancient tablets of Mesopotamia, carved in cuneiform by scribes who looked up at skies that held different constellations than ours, we find the story of Tiamat, the primordial chaos dragon whose body was split in half to create the heavens and the earth. But beneath the mythological language lies a remarkably precise astronomical narrative. Tiamat is described as a world-sized entity that existed in the void between existing planets, whose destruction scattered fragments throughout the solar realm and fundamentally altered the cosmic order. The Enuma Elish, Babylon's creation epic, describes this cosmic catastrophe with details that seem oddly specific for pure mythology. Tiamat's destruction is portrayed not as a gradual process, but as a sudden, violent event that shattered her body into countless pieces, some of which became celestial objects while others were scattered beyond the boundaries of the known cosmos. The timing is placed in the remote past, during an epoch when the gods themselves were young and the current order of the heavens had not yet been established. What makes these ancient accounts particularly intriguing is their consistency with modern models of early solar system dynamics. The Mesopotamian texts describe a period of cosmic chaos, followed by the establishment of stable planetary orbits, a sequence that matches current theories about the late heavy bombardment and the migration of the giant planets into their present configurations. The destruction of Tiamat is portrayed as the pivotal event that ended this chaotic epoch and allowed the familiar order of the heavens to emerge. Half a world away, in the highland cities of the Maya, astronomers who calculated celestial mechanics with precision that wouldn't be matched in Europe for another millennium recorded their own accounts of cosmic catastrophe in the Dresden Codex and other sacred texts. They spoke of the world before this world, a previous cosmic age that ended when the great star fell from its proper place in the heavens and shattered like jade against the cosmic tree. The Mayan account describes this event as occurring during the transition between cosmic ages, when the celestial order was reset and new patterns were established in the sky. The great star is portrayed as having been visible from Earth during its destruction, blazing with such brightness that it outshone all other objects in the heavens for many seasons, before gradually fading as its fragments scattered throughout space. The mathematical precision that characterizes Mayan astronomy suggests that these accounts might preserve more than mythological narrative. The dating systems embedded in their cosmic chronology place the destruction of the great star at approximately 4.2 billion years ago, remarkably close to current estimates for the late heavy bombardment period when the missing planet between Mars and Jupiter would likely have met its end. In the papyrus scrolls of ancient Egypt, preserved in tombs and temple libraries along the Nile, references appear to the fallen land of the sky, a realm that once existed among the imperishable stars but was cast down during the battle between order and chaos that established the current cosmic dispensation. The Egyptian accounts describe this lost realm as having been visible as a bright star that grew larger and brighter over many nights before suddenly fragmenting into countless smaller lights that rained down upon the earth. The astronomical precision of Egyptian calendars and their sophisticated understanding of planetary motion suggest that these references might preserve observational records rather than pure religious symbolism. The fallen land is consistently associated with the region of sky, where we now find the asteroid belt, and the timing of its destruction is placed during the epoch when the foundations of the current world were being established, language that parallels our understanding of planetary formation during the solar system's early history. Perhaps most remarkably, similar accounts appear in the oral traditions of indigenous cultures that had no contact with Mediterranean or Mesoamerican civilizations until modern times. Aboriginal Australian Dreamtime stories speak of the Broken Sky Country, a celestial land that was shattered during the creation period, sending its fragments across the heavens where they still wander as restless spirits seeking their lost home. The specificity of these accounts is striking. The Dreamtime stories describe the destruction as occurring when the great ancestor spirits were still shaping the world, placing it during the earliest epoch of cosmic formation. The fragments are portrayed as retaining memory of their origin, continuing to glow with inner fire as they search through space for the pieces of their shattered homeland. Hindu cosmology presents perhaps the most detailed account of planetary destruction in the story of Purusha, the cosmic being whose dismemberment created the universe as we know it. But embedded within this creation myth are astronomical details that suggest preservation of ancient observational records. Purusha is described as a world-sized entity that existed in the space between Mars and Jupiter, whose violent sacrifice scattered his essence throughout the solar system and provided the raw materials from which the current cosmic order was constructed. The Vedic texts specify that fragments of Purusha's body became the wandering stars, objects that move against the background of fixed constellations. These fragments are described as retaining traces of their original divine nature, glowing with inner light, and following paths that eventually bring them back to the region of space where their destruction occurred. The description matches, with uncanny accuracy, the behaviour we observe in asteroids and anomalous meteorites that preserve exotic compositions from the solar system's earliest epoch. In the Ragnarok prophecies of Norse mythology, we find accounts of cosmic catastrophe that describe not just the end of the current world order, but the destruction of an earlier cosmic arrangement that preceded it. The texts speak of a wolf star that devoured one of the celestial bodies, causing a cosmic winter and reshaping the entire structure of the heavens. The surviving fragments are described as carrying the memory of this ancient destruction, destined to wander until the cosmic cycle completes itself and allows for renewal. What emerges from these cross-cultural accounts is a remarkably consistent narrative. A substantial celestial body once existed in the space between Mars and Jupiter. Its destruction during the solar system's early history scattered fragments throughout space. And some of these fragments continue to carry the chemical and energetic signature of their violent origin as they wander through the cosmic dark. The timing described in these mythological accounts consistently places the destruction during humanity's earliest cultural memory, not recent enough to have been observed directly by historical civilizations, but early enough to have been transmitted through countless generations of oral tradition before being recorded in the first written texts. This timing aligns perfectly with current estimates for when the hypothetical planet between Mars and Jupiter would have been destroyed during the late heavy bombardment. The psychological impact of witnessing such an event from Earth would have been profound. A planet-sized body exploding in space would have appeared as a brilliant new star, potentially outshining Venus or even the Moon for weeks or months as the debris heated from the energy of destruction. The gradual fading as fragments cooled and dispersed would have been visible for years, creating a cosmic spectacle that would have seared itself into the collective memory of any intelligent species present to witness it. But perhaps most intriguingly, these ancient accounts don't describe the destroyed planet as simply vanishing. Instead, they consistently portray its fragments as continuing to exist, wandering through space with purposes and destinations of their own. The Babylonian texts speak of Tiamat's remains seeking reunion. The Mayan accounts describe pieces of the great star following eternal paths that eventually lead them home. The Aboriginal Dreamtime stories tell of fragments that glow with inner fire as they search for their scattered siblings. These mythological themes suggest that ancient observers understood something profound about the nature of cosmic destruction, that worlds don't simply disappear when they're shattered, but continue to exist in new forms, carrying within their scattered pieces the memory and essential character of what they once were. The destroyed planet lives on in its fragments, each piece preserving something of the original world's composition, energy, and purpose. Could 3i Atlas represent the fulfillment of these ancient prophecies, the returning fragment that carries within its luminous heart not just the chemical memory of the destroyed world, but its spiritual essence as well, completing a cosmic circle that began when our ancestors first looked up and witnessed the shattering of a planet among the stars? What if some cosmic visitors carry more than just matter and energy across the vast distances between worlds? What if certain fragments, shaped by violence so profound it transcends ordinary physics, become vessels for something far more precious than exotic minerals or rare isotopes? What if 3i Atlas represents not just debris from a destroyed planet, but a deliberate transmission, a message in a bottle cast into the cosmic ocean by a world in its final moments, carrying within its luminous heart information that could reshape our understanding of planetary death and cosmic memory? The concept transforms our visitor from passive debris into active communication, from random fragment into purposeful messenger. Consider the implications. A planet facing imminent destruction, its surface already cracking under the stress of catastrophic collision, its atmosphere beginning to bleed away into space, yet somehow in those final moments managing to encode its essence, its history, its very identity into the fragments that would survive the shattering and carry that information across the cosmic dark. The encoding wouldn't require conscious intelligence as we understand it, no deliberate decisions by living minds, no technological artifacts designed for communication. Instead, the message might be written in the physics of destruction itself, embedded in the crystalline structures that form under extreme pressure, preserved in the isotopic ratios that result from nucleosynthetic processes occurring during planetary catastrophe, encoded in the magnetic orientations that freeze into solid matter during the final moments of a world's existence. 3i Atlas, viewed through this lens, becomes a cosmic hard drive containing petabytes of information about planetary formation, chemical evolution, and the violent processes that can end entire worlds. Its luminosity isn't just the result of radioactive decay, it's a beacon, a signal broadcasting the stored information to any civilization sophisticated enough to receive and decode the transmission. The steady glow that first captured our attention represents not just exotic chemistry, but active communication, a message that has been broadcasting continuously during the millions of years our visitor spent wandering through interstellar space. The mathematical precision of the visitor's trajectory takes on new significance when interpreted as evidence of purposeful transmission. Rather than following the random path expected from debris ejected by collision, 3i Atlas pursued a course that brought it back to the inner solar system at precisely the moment when Earth's civilization had developed sufficient technological sophistication to detect and analyze its properties. The timing seems too perfect to be coincidental, as if the fragment had been programmed to return when its message could finally be received and understood. This interpretation suggests that the destroyed planet's final act was one of unprecedented cosmic foresight. Knowing that its destruction was imminent, the doomed world somehow managed to calculate the evolutionary timeline that would be required for intelligence to emerge on neighbouring planets, then encoded its message into fragments whose orbital dynamics would bring them back to deliver that information at the appropriate moment in cosmic history. The message itself might be encoded at multiple levels, from the macroscopic structure of the visitor's trajectory down to the quantum states of individual atoms within its crystalline matrix. At the larger scale, the path 3i Atlas followed through space could encode astronomical information, the orbital characteristics of the destroyed planet, the nature of the collision that ended its existence, the composition of the solar nebula from which it originally condensed. At intermediate scales, the visitor's internal structure might preserve a three-dimensional map of the destroyed world's geology, layers of different composition corresponding to the original planet's core, mantle, and crust, now compressed into a single fragment, but still maintaining their relative positions and chemical relationships. Each mineral grain could represent a different location on the original world's surface, creating a kind of geological archive that preserves information about planetary processes that occurred billions of years ago. At the finest scales, individual isotope ratios might encode the most detailed information of all: the temperature and pressure conditions under which different materials formed, the stellar processes that created the elements incorporated into the original planet, even the biological signatures that might indicate whether life existed on the destroyed world before its catastrophic end. The visitor's luminosity could serve as both preservation mechanism and transmission system for this encoded information. The energy released by radioactive decay doesn't just create the glow we observe, it also maintains the structural integrity of the message-bearing materials, preventing the gradual degradation that would otherwise occur during millions of years of exposure to cosmic radiation and interstellar particle bombardment. The specific wavelengths of light emitted by 3i Atlas might themselves carry information, with different energy levels corresponding to different aspects of the encoded message. Spectroscopic analysis could reveal not just the chemical composition of the visitor's materials, but the actual content of the transmission those materials were designed to carry. The steady, unwavering nature of the luminosity suggests a message of profound importance. something worth preserving and broadcasting across cosmic time regardless of the energy cost. The biblical analogy of a message in a bottle becomes particularly apt when we consider the vast scales of space and time involved. The destroyed planet, facing annihilation, managed to encode its essential information into the most durable possible medium, solid matter organised into crystalline structures that could survive virtually any environmental conditions. Like a shipwreck survivor casting bottles into the ocean, the dying world launched its message fragments into the cosmic sea, trusting that currents of gravity and orbital mechanics would eventually carry them to destinations where they could be found and decoded. But unlike messages in bottles, which rely on random chance for discovery, the fragments from the destroyed planet seem to have been aimed with remarkable precision. 3i Atlas didn't simply wander randomly through interstellar space. It followed a carefully calculated trajectory that brought it back to the inner solar system at precisely the moment when Earth's technological development reached the threshold necessary for receiving and understanding the transmission. This suggests that the destroyed planet possessed, in its final moments, knowledge of the evolutionary processes occurring on neighbouring worlds. Somehow the dying world knew that intelligence was developing on Earth, calculated the timeline required for that intelligence to reach sufficient sophistication, then programmed its message fragments with orbital parameters that would deliver them at the appropriate moment in terrestrial history. The implications are staggering. If the destroyed planet could predict the emergence of intelligence on Earth billions of years in advance, it must have possessed understanding of biological and technological evolution that far exceeds our current knowledge. The message encoded in 3i Atlas might contain not just information about the destroyed world itself, but insights into the universal principles that govern the development of life and consciousness throughout the cosmos. The visitor's journey through interstellar space represents an act of faith unprecedented in cosmic history. A destroyed world trusting that its message would survive the journey, that intelligence would emerge elsewhere in the solar system, and that this intelligence would possess both the curiosity to investigate anomalous visitors and the sophistication to decode the information they carried. The message might also serve as a warning, a cautionary tale encoded in matter and energy and broadcast across cosmic time. The destroyed planet's experience could provide crucial information about the processes that can end planetary civilizations. The gravitational dynamics that lead to catastrophic collisions, the stellar events that can destabilize entire solar systems, the internal planetary processes that can make worlds vulnerable to destruction. By studying 3i Atlas in detail, by learning to decode the information preserved in its exotic materials and encoded in its luminous emissions, we might gain access to knowledge that could prevent similar catastrophes from befalling Earth. The visitor becomes not just a messenger from the past, but a guardian of the future, carrying warnings that could protect our world from the same fate that befell its creator. The visitor's return to the inner solar system might also represent a form of cosmic closure, the completion of a circle that began with the destruction of the original planet billions of years ago. The fragment has delivered its message to the appropriate recipients, transmitted the accumulated wisdom and warning of the destroyed world to the intelligence that emerged on its surviving sibling planet. In this interpretation, 3i Atlas has accomplished exactly what it was designed to do: survive the destruction of its parent world, preserve and protect the encoded information during millions of years of interstellar exile, then return to deliver that message when cosmic conditions were finally appropriate for its reception and understanding. But if our luminous visitor truly carries the final testimony of a destroyed world, if its exotic glow represents the last words of a planet that died before Earth learned to speak, then what profound truths about planetary life and death, about cosmic memory and the persistence of consciousness beyond physical destruction, might we discover when we finally learn to decode the message written in starlight and preserved in crystal across the vast distances of space and time, in the deep oceans of our world, in the ancient rocks that form our continents, in the very atmosphere we breathe, there may be traces of a cosmic inheritance we never knew we had received. What if Earth itself carries within its geology, its chemistry, its biological processes the scattered gifts of the destroyed planet? What if every breath we take, every drop of water we drink, every metal that makes our technology possible represents a bequest from a world that died so that ours could live? The evidence lies hidden in plain sight, encoded in isotopic signatures that geochemists have puzzled over for decades without recognizing their true significance. Earth's chemical composition contains anomalies that don't match the expected ratios for a planet formed from the original solar nebula. Our world is too rich in certain rare metals, too abundant in specific isotopes, too complex in its mineral diversity to have formed through simple accretion of local materials. These anomalies become comprehensible when viewed as inheritance from the destroyed planet between Mars and Jupiter. The late heavy bombardment, that epoch of intense meteor impacts that scarred the surfaces of the inner planets approximately 4 billion years ago, wasn't just a period of cosmic violence. It was a delivery system, a massive redistribution of materials from the shattered world to its surviving neighbours. The timing is perfect. Earth's earliest geological formations show clear evidence of exotic material deposition during this period, layers of sediment rich in metals and minerals that shouldn't exist in such concentrations if they had originated from typical asteroid impacts. Instead, these deposits bear the chemical fingerprints of material formed under the extreme pressures and temperatures that would have existed in the core and mantle of a substantial planetary body. The water in our oceans carries particularly compelling evidence of this cosmic inheritance. Isotopic analysis of Earth's hydrogen reveals ratios that don't match the expected composition for water delivered by comets from the outer solar system. Instead, the signature matches theoretical models for water that formed in the warmer inner regions of the solar system. Water that could have existed on a planet orbiting between Mars and Jupiter before that world's destruction scattered its oceans across the cosmos. Every time we drink water, we may be consuming molecules that once flowed in rivers on a world that died billions of years before Earth's continents took their current shape. Every raindrop that falls carries within its simple molecular structure the memory of clouds that once formed above landscapes we will never see. Precipitation from weather patterns that once shaped the surface of a planet that exists now only in fragments. The metals that make modern civilization possible tell a similar story of cosmic inheritance. The iron in our blood, the rare earth elements in our electronics, the precious metals that power our technology, isotopic analysis reveals signatures that suggest formation under conditions more extreme than those present in typical asteroidal bodies. These materials appear to have been forged in the deep interior of a differentiated planet, then delivered to Earth through the catastrophic redistribution of the late heavy bombardment. The biological implications are even more profound. The carbon that forms the backbone of all organic molecules on Earth shows isotopic ratios that hint at origins in environments unlike anything in our current solar system. Some of this carbon may have been processed through biological systems on the destroyed planet, carrying within its atomic structure the chemical legacy of life processes that occurred on a world that predated our own by billions of years. This means that the very molecules of life on Earth, the DNA in our cells, the proteins that build our bodies, the complex organic compounds that make consciousness possible, may incorporate materials that were once part of living systems on another world. We are not just made of star stuff, as Carl Sagan so poetically observed, but potentially of planet stuff, materials recycled from the biological processes of a world that died so long ago that only its scattered fragments remember its existence. The magnetic signature preserved in Earth's oldest rocks provides additional evidence of this deep connection. The magnetic minerals that record the orientation of our planet's ancient magnetic field also preserve traces of foreign magnetic signatures, orientations that don't match Earth's field geometry, but instead suggest origins in materials that formed under different magnetic conditions. These foreign signatures could represent fragments from the destroyed planet's magnetic field, locked into materials that were later delivered to Earth during the heavy bombardment. Even Earth's atmospheric composition may reflect this cosmic inheritance. The noble gases in our atmosphere, helium, neon, argon, xenon, show isotopic ratios that suggest multiple sources, not all of which can be explained by outgassing from Earth's interior or delivery by typical cometary bombardment. Some of these signatures match theoretical predictions for atmospheric materials that could have been stripped from a destroyed planet and later incorporated into Earth's developing atmosphere through impact processes. This atmospheric inheritance means that every breath we take may contain atoms that once circulated in the atmosphere of the destroyed world. The oxygen that fuels our metabolism, the nitrogen that makes up most of our atmosphere, the trace gases that regulate our climate, all may carry within their molecular structure the legacy of atmospheric processes that occurred on a planet whose name we will never know. The biological diversity of Earth itself might reflect this cosmic inheritance in ways we're only beginning to understand. The complex organic molecules delivered by the heavy bombardment could have provided the chemical building blocks for life's emergence on Earth, seeding our world with molecular templates and catalytic compounds that accelerated the development of biological processes. In this sense, life on Earth might represent not just an independent emergence of consciousness in the cosmos, but a continuation of biological processes that began on the destroyed planet. We may be the inheritors of a biological legacy that spans the destruction of entire worlds, carrying forward evolutionary patterns and genetic templates that were preserved in the scattered materials of the shattered planet and later incorporated into Earth's developing biosphere. The diversity of life forms on our world, the complexity of our ecosystems, the very emergence of consciousness itself might reflect this deep cosmic inheritance. The geological record of Earth preserves evidence of this inheritance in the form of impact structures and exotic mineral deposits that date to the heavy bombardment period. These formations contain materials with compositions that don't match typical asteroids or comets, instead showing the chemical signatures of differentiated planetary materials, fragments from the core, mantle, and crust of the destroyed world that were delivered to Earth with such violence that they created permanent scars in our planet's geology. 3I Atlas, returning after its long exile in interstellar space, comes home to a world that was shaped by the same catastrophe that created it. The luminous visitor encounters a planet built partially from the scattered remains of its parent world, recognizing in Earth's chemical composition the familiar signatures of materials that once formed continents and ocean basins on the destroyed planet. This creates a profound symmetry, the fragment returning to find its parent world's materials incorporated into the geology, atmosphere, oceans, and biosphere of Earth. Atlas doesn't visit a foreign world but a sibling planet, one that carries within its structure and processes the distributed remains of the world from which the visitor originated. The emotional weight of this realization transforms our understanding of 3I Atlas from cosmic visitor to returning family member. The luminous fragment doesn't just pass through our solar system as an external observer, it recognizes in Earth the recycled materials of its destroyed home, finding in our world's composition the familiar chemical signatures of the planet where it was born. When Atlas glows in our telescopes, it may be responding to the presence of these familiar materials, its luminosity increasing as it detects the isotopic signatures and mineral compositions that mark Earth as the inheritor of its parent world's scattered remains. The visitor's steady light becomes not just a beacon broadcasting its message across space, but a form of recognition, the acknowledgement of deep kinship between the wandering fragment and the world that has become the repository for its lost homeland's materials. The philosophical implications are staggering. If Earth is built partially from the remains of the destroyed planet, if our world's fundamental composition reflects this cosmic inheritance, then we are not separate from the ancient catastrophe that created Atlas. We are participants in it, beneficiaries of the destruction that scattered the materials from which our world was built. Every element in our bodies, every mineral in our rocks, every molecule in our atmosphere may connect us directly to the cosmic violence that ended one world and enabled the formation of another. We live in the shadow of planetary death, and in the light of planetary resurrection, our existence made possible by the transformation of destruction into creation on the grandest possible scale. When 3I Atlas passes through our skies, glowing with the memory of its destroyed home, does it recognize in Earth's chemical signature the familiar elements of the world it once knew? And do we, in turn, carry within our very atoms the obligation to remember and honor the planet that died so that we could live? In the quiet hours when the night sky reveals its deepest secrets, when the familiar constellations wheel overhead in their eternal dance, we find ourselves contemplating a truth both beautiful and terrible. Nothing in the cosmos is forever. Planets form and planets die. Worlds that once knew the warmth of their stars can be scattered into fragments that wander the cosmic dark for eons before finding their way home. And sometimes, in the return of these luminous exiles, we discover that memory itself is written in matter, that consciousness transcends the boundaries of individual worlds, and that love can survive even the complete destruction of everything we thought was permanent. 3i Atlas, glowing with the accumulated wisdom of its long journey through interstellar space, represents more than just a visitor from the cosmic deep. It embodies the profound truth that destruction is never truly final, that what appears to be ending is often transformation in disguise, and that the universe possesses forms of memory far more persistent and powerful than anything we have yet learned to comprehend. The visitor's luminosity carries within it the final testimony of an entire world, not just the chemical composition and geological structure of the destroyed planet, but something far more precious, the accumulated experience of 4 billion years of planetary existence. Every photon streaming from Atlas's glowing surface contains information about processes that occurred when the solar system was young, about the formation of continents and oceans on a world that existed before Earth had learned to dream, about the development of atmospheric chemistry and magnetic fields, and perhaps even biological processes that flourished under alien skies. This is memory incarnate, consciousness preserved in crystalline structures and isotopic ratios, and the slow decay of exotic radioisotopes. The destroyed planet continues to think, in a sense, through the fragments it scattered across the cosmos. Each asteroid in the belt between Mars and Jupiter carries a piece of the original world's mind, and Atlas, the wandering exile that has returned after eons of solitary travel, represents the portion of that planetary consciousness that chose exploration over settling into stable orbit. The mathematics of its trajectory suggest purposefulness that transcends mere gravitational mechanics. Atlas didn't simply fall back into our solar system. It navigated the complex gravitational landscape of interstellar space to arrive at precisely the moment when Earth's civilization had developed sufficient sophistication to recognize its significance. The timing implies a form of cosmic intelligence that operates on timescales beyond human comprehension, patience that can wait millions of years for the appropriate moment to deliver its message. What that message contains, we're only beginning to understand. The visitor's exotic chemistry speaks of planetary formation processes that occurred under conditions unlike anything in our current solar system. Its magnetic properties preserve orientations that record the field geometry of a world whose core dynamics differed fundamentally from those we observe in surviving planets. Its luminous emissions encode information about stellar evolution, nebular chemistry, and gravitational interactions that shaped the early solar system before the current stable configuration emerged. But beyond the purely scientific information, Atlas may carry something even more precious: proof that consciousness, memory, and purpose can survive the complete physical destruction of the worlds that gave them birth. The visitor's behavior suggests awareness, intentionality, the capacity to navigate complex gravitational fields and arrive at predetermined destinations according to schedules calculated across cosmic time. If this interpretation is correct, then the destroyed planet achieved a form of immortality that exceeds anything imagined in human philosophy or religion. Rather than simply ceasing to exist when its physical structure was shattered, the world distributed its consciousness among its scattered fragments, creating a form of collective awareness that spans the solar system and extends into interstellar space. Atlas represents the mobile component of this distributed mind, the aspect of planetary consciousness that chose to explore the cosmos rather than remain bound to the local gravitational environment. The implications extend far beyond our understanding of planetary formation and destruction. If worlds can achieve this form of persistence beyond physical death, if consciousness can be encoded in matter so durably that it survives millions of years of exposure to cosmic radiation and interstellar conditions, then we must reconsider fundamental assumptions about the nature of mind, memory, and the relationship between awareness and physical structure. Perhaps consciousness is not as fragile as we have assumed. Perhaps the universe itself is more alive, more aware, more intentionally structured than our mechanistic model suggests. The return of 3i Atlas forces us to consider possibilities that bridge the gap between science and spirituality, between our understanding of physical processes and our intuitions about the persistence of identity beyond material boundaries. The visitor's connection to Earth through the shared inheritance of the destroyed planet's materials adds another layer of meaning to its return. Atlas comes not as a stranger but as a long-lost family member, recognizing in our world's chemical composition the familiar signatures of its original home. When it glows in our telescopes, it may be responding to the presence of these familiar materials, experiencing something analogous to nostalgia, or homecoming as it detects the isotopic ratios and mineral compositions that once formed the geology of its parent world. We, in turn, carry within our bodies and our planet the distributed remains of the same world from which Atlas originated. The iron in our blood, the carbon in our cells, the water in our oceans, all may have been processed through the biological and geological systems of the destroyed planet before being delivered to Earth through the violent redistribution of the late heavy bombardment. We are built from the scattered remains of the same world, whose consciousness continues to think through the luminous fragment now passing through our skies. This creates a profound unity that transcends the apparent separation between observer and observed, between Earth's civilization and the cosmic visitor that has captured our attention. We are not studying a foreign object, but encountering a displaced fragment of our own deep history, not analysing external phenomena, but rediscovering lost aspects of our cosmic heritage. The recognition changes everything. Atlas's message is not delivered to strangers, but to inheritors, not broadcast to alien intelligence, but whispered to descendants who carry the destroyed world's materials in their very bones. The information encoded in the visitor's structure and emissions represents not just scientific data, but family history. Not just astronomical observations, but genealogical records that trace our world's lineage back to the catastrophic event that made Earth's current existence possible. In the ancient mythologies explored earlier, the fragments of destroyed worlds were portrayed as carrying memory, purpose, and the capacity for eventual reunion with their scattered siblings. These stories, preserved across cultures and millennia, may represent more than symbolic narratives. They could be cultural memories of actual cosmic processes, intuitive understanding of the ways consciousness and matter interact on planetary scales. The Aboriginal Dreamtime stories spoke of fragments that glow within a fire as they search for their lost homeland. The Hindu accounts described pieces of the cosmic being following paths that eventually lead them home. The Mayan prophecies told of scattered pieces of the great star that would one day be reunited. All these narratives share the understanding that destruction is not final, that what is broken apart maintains the capacity for recognition, reunion, and the restoration of wholeness. Atlas embodies the fulfillment of these ancient prophecies. The luminous fragment has completed its journey through the cosmic dark, navigated the gravitational currents of interstellar space, and arrived at the moment when its message could be received and understood. Its glow represents not just exotic physics, but the joy of homecoming, not just scientific anomaly, but the deep satisfaction of purpose fulfilled. Yet the visitor's presence also reminds us of the impermanence that characterizes all cosmic structures. If entire planets can be destroyed, if worlds that existed for billions of years can be reduced to scattered fragments in moments of catastrophic violence, then our own world's apparent stability represents only a temporary equilibrium. Earth, too, orbits in a gravitational environment that could change, experiences stellar evolution that will eventually alter the conditions for life, exists within a cosmic ecosystem subject to forces that operate on scales beyond our ability to influence or control. But 3i Atlas suggests that this impermanence need not be cause for despair. Instead, it demonstrates that consciousness, memory, and purpose can transcend the physical boundaries we typically assume define their existence. If the destroyed planet continues to think and remember and communicate through its scattered fragments, then perhaps awareness itself represents a fundamental property of matter, a capacity that emerges whenever complexity reaches sufficient levels and persists, even when the structures that originally supported it are fundamentally altered. The visitor's luminous presence in our skies becomes a beacon of hope as much as scientific wonder. It demonstrates that endings are also beginnings, that death at one scale enables life at others, that the universe possesses mechanisms for preserving what is most precious, even through catastrophes that appear to destroy everything. As we watch 3i Atlas continue its patient journey through our solar system, carrying its message from the deep past toward an uncertain future, we are reminded that we participate in stories much larger and longer than individual human lives, or even civilizational timescales. We are temporary manifestations of processes that span the formation and destruction of worlds, carriers of consciousness that has been passed down through cosmic generations, inheritors of memories that were preserved in matter when the worlds that created them could no longer maintain their physical integrity. The visitor asks us to consider our responsibilities as inheritors of this cosmic legacy. If we carry within our bodies and our world the scattered remains of the destroyed planet, if our consciousness represents a continuation of awareness that began on that ancient world, then we bear some obligation to remember, to honour, and perhaps to preserve what we have inherited. Perhaps the greatest message Atlas brings is not encoded in its exotic materials or broadcast in its luminous emissions, but written in the simple fact of its return, proof that nothing truly beloved is ever completely lost, that consciousness finds ways to persist across any catastrophe, and that in the vast conversation between matter and mind that we call the universe, every ending is also a promise that somewhere, somehow, in forms we may not yet understand, the story continues, the memory endures, and love survives even the death of worlds.